So let's talk about the group of different molecular geometries you get if you have two periphery atoms. Now to do this, we're going to take a look at starting with the electronic geometry, the AY, and then using that to go back to the molecular geometries. So we have 5 possibilities if we have two periphery atoms: AY2, AY3, AY4, AY5, and AY6. So if we look at their equivalent molecular geometries, if we have AX2, we can't have any lone pair atoms, lone pair electrons in the central atom because our molecular geometry, electronic geometry, got the same number. If we go to AY3, this is going to be AX2E1, AX2E2 for AY4, AX2E3 for AY5, and AX2E4 for AY6. So, in order to figure out what the molecular geometry is, what we're going to do is we're going to start picking off periphery atoms. So if we go to AX2, well, we have the same number of electronic domains as we do periphery atoms, so this is what it looks like. And we would call this a linear molecular geometry. So again, if your number of X groups equals your number of Y groups, you end up getting the exact same electronic and molecular geometries. Let's say you go to AX2E1. Well, one of these domains is going to disappear because it's a lone pair, and what we end up is getting a bent shape. So even though it is really trigonal pyramidal with regard to the AY notation, the electronic domains, we only see the periphery atoms, so those lone pairs are going to push those periphery atoms at an angle, and it looks bent. And this is going to be the same thing for the AX2E2. Our two lone pair groups, our E2s, are going to disappear, and one's going to get in and recover the bent. Now the weird one here is the AX2E3 because we have axial and equatorial. Now in all cases, our lone pair electrons are going to go into the equatorial positions. So they're going to disappear along the equator, and we get, once again, a linear molecular geometry. So far, linear, bent, bent, and linear. As far as this one, this does not exist. And the reason this does not exist is that we would have to have an atom that exceeds 8 in its valence shell before it even begins bonding. So in terms of the molecular geometries that are possible with X2, we can never get to an AY6 electronic domain. So these, basically you have two options, linear and bent. You're going to have bent if you have any lone pairs up until you get to 3, and then you can go back to linear again.